Hello and welcome to this Automation Academy Mastering the Machine webinar for the 9th of December 2023. My guest today is Phil Scruggs, and he is going to be presenting a control system that he put together for the Olbrich Arts interactive display back in fall 2023 in Madison, Wisconsin. Very interesting presentation where he used an open source home assistant, some ESP 8266 relays, and a Raspberry Pi to put together an interactive arts display. A very, very interesting presentation. And I'm also going to be talking a little bit about my Mastering the Machine workshops coming up in January. And hope you enjoy the presentation. Thank you. Welcome to this episode of Mastering the Machine and presentation from the Automation Academy and NTH University. And this is the 67th webinar. I'm now keeping track of that, eagerly trying to hit 100 eventually here. I've been doing it for about 3 years now. This is the 9th of December, so we're just into the third year. And my guest today is Phil Scruggs. And Phil was, I believe, in the first webinar that I did, probably in November of 2020, when I first got the Automation Academy started. So he is back and going to be showing us some fun stuff today. Before we get going too crazy here, a little bit of an ad here. This is sponsored by the Automation Academy, which is my membership site. You can find more on that at these two websites here, automationllc.com or on the Automation Primer, which is just a blog. We do have training videos for Allen Bradley, Siemens, Beckhoff, Omron, soon to be Automation Direct. I'm going to be doing a bunch of webinars on the free software that Automation Direct has that you can simulate on. So if you do want to get started in PLC programming on a free platform, that's a pretty good one. And it kind of mimics the book that I put out called PLC Hardware and Programming Multi-Platform. So it's a very easy way to use the software and do a lot of those exercises without paying anything for it, which has been one of my frustrations. We do have a community with interest groups called IO Central. Almost nobody ever goes there, but hey, it's there and you can create a profile and there's interest groups and things like that. I check in every once in a while to see if anybody's lurking, and so far there's no lurkers there, which may be good if you want to go there and just hang out without lurkers watching you. And we do have regular events here, these Mastering the Machine webinars. Try to do them every 2 to 3 weeks. We will be doing another one, I think, just after Christmas. Still one left to go this month. Anyway, you can find the Automation Academy at this website, automationllc.com, or communityautomationllc.com for IO Central. One of the things that I wanted to talk about this morning, I have a blog post on this about all the different things that you need to learn to get into industrial automation. There are lots and lots of PLC classes out there. And of course, I teach some of those. I travel around the country and teach for a company called Automation Training. I do teach my own classes here at my facility. But it's not just about PLC programming, right? There are lots and lots of other things, some of which you need to know before ever getting to PLCs. So I kind of created this little graphic here. You know, reading, writing, and arithmetic, as they used to call it, is the stuff that you learn in high school, middle school, whatever. And then after you get out of high school, or maybe even while you're in high school, you'll take maybe some advanced math, physics, chemistry, things like that. Maybe get into electronics, basic electricity or logic, and then maybe go to a tech school or something like that, where hopefully you'll get something on motors, fluid power, that sort of thing. So before you ever get to PLCs, you really need to know a lot of other things. You need to know some kind of special math, numbering systems, Boolean algebra, things like that. There's a lot of basics of controls to know. Different processes. You know, if you've ever worked in a plant, you'll see what kind of processes are available. So I kind of built this little pyramid showing some of the basics you need to know before you ever even get to PLCs or DCSs or whatever you do. So these are some of the different things that I'm going to be presenting in my Mastering the Machine workshops. And these workshops are live events, and I'm doing my first one here in January. And the reason I'm doing this is I had somebody that really wanted to go to NTH University. And NTH University is a 4-month internship. And I don't think they understood that it wasn't a class. It is an internship or apprenticeship with the hopes of Automation NTH hiring people that already have the skills that they need to do the job at NTH, right? So a lot of times you start a new job and you'll be 6 months just learning what things are about, and not necessarily being able to provide value to the company. But Automation NTH 5-6 years ago created on NTH University to train people out of college, even while they're in college, maybe their final year, and do an internship and learn PLC programming and CAD and panel building. They'll put them in the panel shop, things like that, and do a lot of hands-on. And so this guy contacted me through NTHU and really wanted to take this class. And he kind of was very insistent that he was willing to pay for a whole bunch of time. So I said, well, it's very difficult to teach one student at a time, though I have, and I can probably theoretically break even if I do that. But what I did is I opened this up when this guy is coming. He's coming for 2 weeks in January, and I opened this up to anybody. And I quickly got a couple people from Miami, from my big customer down there, that the owner of the plant down there wanted to send a couple people up to learn a little bit of everything, PLC programming, do a lot of hands-on and that sort of thing. So now I have basically 3, and though it says I'm limited to 4 here, I'm actually limited to 5. I can take up to 5 people, and people can sign up for this class even for 1 day. If you want to come up and just take 1 day of training, and it'll be on kind of your own chosen curriculum. I give you something like this, and you fill out these check boxes, and you fill out what platform do you want to learn? Do you want to learn Allen Bradley, or do you want to learn Omron or Automation Direct Beckhoff? You wouldn't want to start with Beckhoff, which is one of the reasons I'm going to start out with some of this kind of Automation Direct or basic Allen Bradley stuff before ever moving somebody into Beckhoff. But anyway, that's what this is. This workshop is about in January. And if you want to sign up for this, there's still room for 1 to 2 people for just about all the days. And if you just want to pick a day or 2 days or 5 days, I have a few people that are looking at this, a couple people from Chicago and a couple people from here in Nashville that may come in and take at least part of the days. So it's going to be an open workshop, lots and lots of different subjects. And in preparation for it, I remodeled this room. So this is a kind of a funny looking room. It was I think a garage at some point, or so they say. This is an old house that I'm in. And this used to have carpet in it. And I used it kind of for storage, and I did build a little project in here. But I had some folks come in and do this floor using epoxy, and I had them put pegboards all over the walls. And you can see behind me, there's a little bit of pegboard here and a shelf. I keep all my trainers on that. And then I put pegboards on the walls. And also, you can see this mill. This is a little mini mill at my house in my garage. I'm going to be moving that here. And that actually fits in that little space there to the right of that fireplace. Now, you might ask, why is there a fireplace in a garage? I don't have a clue. I really don't know. But this was a garage. I can tell because a drop ceiling was put in here later. And it has this little stone step thing here that goes up into the main house. So I don't know how this was a garage with an old fireplace in the end of it. But so they say that it was a built-in garage at some point. So anyway, I had the floor epoxied, the carpet taken out, and now it's all nice and empty and ready for my mill and for my new 3D printer. So my 3D printer should be getting here this week, and I'm really eager to get started on that. I have a lot of little toys and trinkets that I need to build parts for. So I'm going to be building legs for my little conveyors and little housings, just like my Fisher Technique stuff that I've showed on here before, so that I can make little operational widgets, hopefully in time for this class, right? So the 3D printer will be here, the mill will be here. I have a whole bunch of pneumatic cylinders that I hope to build into a couple pick and places. Maybe some motor trainers, not really sure about that because that takes a little bit, but people are going to be here and maybe they can even help me build some of this stuff. So that'll give them wiring training, right? They can wire some maybe 480 motors, even if I can get my Tim Wilburn special 120 to 480 volt motor 3-phase converter built. He's done that, and he's put on his website a pretty cool demo of how he did that. I think he went 240, and I do have some 240 single phase here, so may be able to use that. But anyway, that's kind of what I'm up to, the Mastering the Machine workshops. But Phil is here, and Phil is going to tell us a little bit about what he's been working on. Phil's always got fun stuff with microcontrollers and sensors and things. So without any further ado, this is Phil's picture from his LinkedIn. So
yep.
Completely different with his headphones on here. But anyway, this is kind of about a project, and he showed me a little bit of this, and I'll just let him continue with this. How you doing, Phil?
Hey, I'm doing great. Thanks for having me on, Frank, and I'm glad the audio is working well. Let me go ahead and share my screen and we'll get started with this presentation. Basically, it began with a friend who applied for a grant for an art project. And he said, "Hey, Phil, we've got this art project idea. What do you think? Do you think you could help out with it a little bit?" And at the time, I didn't realize how much time and effort it was going to take. But one of the biggest limitations was the cost perspective, right? This is an art project. It's not a standard industrial controls project. So the budget was much more approachable for the average person to understand versus what we're typical to in an industrial environment with devices costing almost obscene amounts of money. So without any delay, I'll go ahead and start the slideshow. Well, one second. Great. So this was an interactive art project in Madison, Wisconsin. So there's a local botanic gardens there, and each year they put on a big art display with multiple people coming in. And the main point of this is to interact with the art. So in order to, get the grant, you have to kind of demonstrate how people are going to interact with such a device or such a installation. Some are more interactive than others. We'll put it that way. Ours ended up being one of the more interactive ones, and that's probably due to, some assistance with some of the automation equipment we're going to show today. So here's some photos of it. It's an interactive art installation, and it ended up being a push button display where different lights will light up to the beat of music. So there's a music component, there's a light component, and then an interactive component where you have to step on different buttons on this dance pad. We had 150 plus flowers that were each individually controlled and 6 dance pads. The dance pads went to one group of flowers. So the dance pads didn't go across the entire display. They only went to a certain grouping of flowers to light up. However, all were simultaneous. So if there were people on each dance pad, yeah, there was quite a light show. Here's a picture in the daytime. It's not as pretty in the daytime, but it is a nighttime display. So this Botanic Gardens was open in the evenings for this. The goal was for it to last 3 months. And we'll show some of the troubleshooting that we went through at different stages in the project. We'll have a tidbit on the advantages of proven systems and industrial control systems opposed to doing a low-cost project like this. But it also demonstrates the feasibility that it can be done with some extra legwork. All right, so first we'll get started with the dance pads. So this is basically the controls where someone would stand on the dance pad and push on the different flower buttons. Inside we have aluminum foil separated by foam. These custom dance pads similar to like a DDR dance mat, if you're familiar with that. And each one of these pads was wired to an input on an ESP32. So this is a small wireless microcontroller device. As you can see, they're very affordable. This one is $6. And let me go ahead and push this video to kind of demonstrate what it looks like in the system when these are being pressed. We'll get into kind of the software behind it in a little bit. But right now we're looking at some of the dance pads and we're scrolling through this. This happens to be on a smartphone. And we'll give it a minute, but you can actually see this is was recorded live when people were dancing on this pad. So these are little switches, and when someone's stepping on the dance pad, it toggles. So right now we're seeing these dance pads toggle through, if I can stop scrolling long enough. But see how these little toggles are going on and off? That's happening when someone's pressing on a button. We're going to get into the details further on in the presentation, but that just kind of explains, hey, these are the dance pads, people step on them, and it's logged in the system. All right, next we're going to get into the flowers. So the flowers were laser cut flowers. I did not participate in this, thankfully, that this was pretty labor intensive. But some of the artists used acrylic to laser cut etchings into different native flowers for the region. So since it is at the Botanic Gardens, there's an element of nature and incorporating some of the local species of flower. So there's irises, there's various sunflowers, there's I'm trying to think of the name of these. These are called coneflowers. So coneflowers are native to Wisconsin. So there's a variety of different wildflowers that were incorporated. So the different flowers had different LED colors. And these were essentially turned on and off with ESP8266 relays. So this is a version of the ESP32 that came out before. It's a little bit cheaper. The cost for these, we spent $2 for the relay and the controller itself. And this is what the package looks like. Since we were on a budget, these went into an enclosure of Tupperware. I'll elaborate on the pros and cons of that later. But this is a photo of what it is. So we've got 120 volts coming in from old extension cords all over the place. We wired it off with a simple converter, 5 volts for the microcontroller and the relay control, 120 volts to the LEDs. The LEDs go through a Meanwell power supply and get reduced to power up the 6 to 8 LEDs per flower. These were pretty bright LEDs. They were about 1 watt a piece. So they would light up the flowers pretty well. And the LEDs were incorporated into various parts of the flower. So to get an understanding, hey, this is the switch. When someone steps on a switch, it turns the flower on or off in a very simple manner to think of it. All right, next we're going to get into kind of the setup for how all these were connected together, right? The control system. So we didn't want to have to stay there 24/7 monitoring this thing. So we set up a Raspberry Pi with a cellular modem so we could log into it from anywhere in the world. These go for about $100. and the cell plans for them are, you know, $10 to $20 per month. 3 months, $60. Home Assistant, we put Home Assistant OS onto the Raspberry Pi. It's very simple to do. It's just like installing any OS onto this device. And we used a generic Wi-Fi router. Let me emphasize, with projects like this, you want to get a new router. We started out with an old router that we had laying around, 5 or 6 years old. It was not up to the task. We'll put it that way. When we started connecting more than 100 plus devices to it, it just could not keep up. I'm not sure what the exact technical reason was. However, when we replaced it with a newer router, most of our challenges went away. Let's go ahead and play this video so we can watch it. So most of these were managed through something called ESP Home. It's a plugin for Home Assistant. It's built into the system, so there's no challenging install process for it. On this device, you actually have the ability to update firmware on each microcontroller over the air. So there's some really cool features on this ESP Home platform. Right now, you can kind of see we're scrolling through all the relays that are attached to this. We just numbered them 1 through 120, basically. And we also have the dance pads in here as well. Notice some of these are offline, online. The offline ones tend to come online. It takes a minute for it to refresh with a heartbeat. Next, we're going to take a look at what it looks like in the logs when people are actively dancing on these pads. So you can pull up the logs and you can watch, hey, someone's stepping on these different buttons. So you can see clicked, released, and this is constant scanning for when someone depresses a button and takes it off. Once someone steps on a button, it sends a message to the API running on Home Assistant. It says, hey, the state of this button has changed, so do something. And we'll keep watching this video and see if anything else. There's one other spot in the video I think was worth seeing. If it loads up, let's see. Nope, I guess that was the end of the video. All right. So these were actual screen recordings several months ago when the installation was live. And I actually recorded these from my cell phone. So you don't always have to have a big laptop to manage and control these projects. You can actually do everything on a cell phone. So say you don't even have a laptop or you can't afford a laptop. Well, if you have a mobile device, you have the potential to program these devices. I wouldn't recommend programming on a cell phone, but you can. And there were some changes that we had to implement while we were on site. And rather than lugging a computer out there, we just took a cell phone. If you want more details about that, that's specifically for the debounce of our dance pad. So anyone in industrial controls knows with push buttons, they're constantly trying to trigger. And if you add a debounce signal or a debounce delay to it, you can kind of prevent those from triggering all the time and actually trigger when someone depresses it for a reasonable amount of time. So we actually made some field adjustments using this, using our cell phones, which was pretty neat. All right, next we have some challenges and lessons learned from implementing a system like this. One, start with equipment that's known to be good. This was done on a budget, so we tried to utilize stuff we had laying around. And with a Wi-Fi router, I think the typical recommended use end of life of a router is 2 to 3 years, maybe just a little bit longer. Probably depending on the quality. We're just talking about consumer grade routers. Hopefully some of the industrial units are longer. But if you go and get a router at Best Buy, you can expect a few years from it. But if it's more than 5 or 6 years old, you might want to check and ensure that it's going to be up to the task. We also had a problem with the dance pads. Aluminum turns out to fatigue. One of the things you mentioned in your slide earlier was chemistry and material science. A basic understanding and knowledge of that goes a long way. So turns out aluminum fatigues a lot faster than other materials. Aluminum foil didn't stand up very well. It lasted about a month with 100 people going through each night stepping on it. So we ended up having to replace this with a slightly more durable dance pad that we constructed and deployed. So thankfully, this was only down for a day or two. And not all the pads failed, just one or two at a time. So we had some pretty good foresight into preventing that. Next, give your devices static IPs. When they were on DHCP, they tended to kind of lose connection every so often and get reassigned a new IP. Home Assistant didn't really like that. It worked a little bit, but I would say there's improvements that could be made. By the time we got everything programmed, it was already set up DHCP. We didn't have time to change it back. But from the beginning, I think next time you'd say, give it a static IP address. That way we know that button 1 is always on this IP address. That gets into the challenges with Wi-Fi in general. So with Wi-Fi, there's going to be some downtime. It's just part of it. I'm, thinking of how we would do this in the future. But I don't know if I would recommend Wi-Fi for an installation like this because everything's pretty close together, right? Most of this can be run with simple short wire runs. I wouldn't say Wi-Fi was a necessity here. Originally, when we were kind of proposing this project, I think there was a thought that maybe each flower would be battery powered. And so Wi-Fi was going to be the option. But as it progressed, we realized we needed to have each one of these powered all the time. Since we're already running wires to it for power, you might as well run wires to it for the controls as well. But it was a great test, and we got to really implement and push the system to its limits. So again, there were 150 plus flowers, 5 dance pads, all on one system being run by a Raspberry Pi. So let me go ahead and grab a photo of the Raspberry Pi, just that. And one other thing to mention, the total budget for this, I mentioned we got a grant for it. The total grant cost was 10 grand, 10,000 total. So that included supplies for all materials, including these dance pads, all of the acrylic, everything like that. So you would think, well, what was the budget for the control system? We spent about $1,000 total for all of the electronics to make this project happen. So if you think about that from a controls perspective, you can get an industrial button and it'll cost 1K for just the button itself. We ended up implementing an entire system for about 1K for this whole art installation. I would recommend, well, I don't know, it ended up working. There are some improvements that could be made, but in a nutshell, it worked. It required a little bit more babysitting than I think we would have liked. Generally, you want to set it and forget it for a while. With this, we pretty much had to monitor it every other night. We would get it. We had to make little changes about once a week and physically go out to the site to kind of make a change. I'm based out of Atlanta, so this was mostly my friend going out there, kind of taking instructions. Hey, unplug this, plug this back in, get it to reconnect. But I would encourage people to take a look at the Home Assistant platform. It ended up working really well for us, and the over-the-air updates were great. we could update things in real time as we needed to. And the platform being capable via cellular or computer, web-based or local, there were really a lot of amazing options with it.
So, was there ever a delay because you're interpreting every button push, but this is in real time, so it's a dance-based thing with music? Was there ever a significant delay that you would notice when somebody would step on a pad and the light would light?
So when it came to lights, there was not much of a delay, right? The delay was insignificant enough to where people wouldn't notice. And what we would do is we would have series of lights happening. So you can actually program automations in Home Assistant. So it's not just a 1-to-1 ratio. When someone steps on a button, sometimes it would trigger a series of lights to happen. So we had a center button, and the center button right there that this person's standing on, that would do a whole series of kind of a light show, basically. So that's pretty neat. We did have some delays with the music. So we did actually wire this up to a speaker as well. We had the dance pad and the speakers wired into the exact same ESP32. It was technically possible or theoretically possible, but we did experience delays with the sound coming from the ESP32 and the button press. So that's something that we'll definitely have to improve if we were to implement the system again in a similar way. There's just not enough horsepower on this to store a sound file, play it when the button is depressed, unless it's local. So if we had this all being done through the API, but that's not the way to do it. You'll definitely need a sound file stored locally. We were able to achieve getting the sound file on it, but that was after the exhibit had been deployed, and we couldn't really make any changes after that. So I will say about halfway through the exhibit, we ended up disabling all the sound and played a background music due to some of the delays. So that was another challenge that ended up being modified. In the end, the exhibit was a success. The interactive component of stepping on the buttons and triggering the light show continued to work consistently throughout the exhibit. We did disable the sound. That was a nice to have feature that definitely added some more to it. But we ended up turning that off about halfway through it and just implementing kind of a background sound that played on loop.
Which is what I would have thought, that could have been an independent thing, that you're just basically streaming music or letting people even select music somewhere, and then just let the sound go. What kind of speakers or whatever did you use? Did they have a sound system out here?
Sure. So initially we wired up basically some cheap speakers directly to this with a little amplifier that you can get. And there's a protocol called I2S. It's similar to I2C, and it's specifically for audio formats. So you can save a sound file either onto the Home Assistant OS device itself and have that play via Wi-Fi, like your Wi-Fi streaming speaker. That was too much delay. That was way too much delay. It did not work. We had several complaints and issues with that. So you can actually store a sound file as a array of the raw sound data on this device itself. So let's go ahead and push play really quick on this video. You can actually see right here. Within Home Assistant, there's actually a media player component. So this is where the Wi-Fi streaming audio comes from. You can stream it from a server. The server being this Raspberry Pi that's hanging out in the background in a box. That introduced too much delay. You can put the raw audio file on here and play directly. We attempted it. We didn't get it quite working. We could play the sound when a button was pressed, But I think just due to too many inputs to this device, it ended up not working as we anticipated. So we ended up stopping that completely and just playing the sound on loop. But it is feasible. It can absolutely be done. And it might make sense with 1 or 2 push buttons, not 9 push buttons plugged into this thing with someone stomping on them all the time. Like if you think of different applications, like a doorbell, for instance, right? Like a smart doorbell, no one's going to go up to your doorbell and push it 10,000 times in 1 minute. So this would work great for that. So say you want a chime when someone pushes a button. Yeah, that could be done. But controlling 8 individual flash file sounds that are flashed onto this device with 9 buttons ended up not being the right pick. So in the future, maybe we'll use a newer ESP32 that's $13 or $20 and has a lot more capability, because we were going for as cheap as possible, and that ended up kind of biting us in the rear end at the end.
Yeah, I'm all about cheap. That's a lot of what I focus on, trying to create, again, training situations where people can work on things without having to spend $10,000. I mean, PLCs, and you found that out, I'm sure, doing this, that it would have been ridiculous, even with an Automation Direct PLC. I think I just paid for a cheap Automation Direct Productivity, was still $650 for a trainer, and I didn't even get the cards that I wanted. I don't even have physical input cards. I just have little switch cards, and I got some relay outputs. But to do what you wanted to do, you get into the industrial world and you're very quickly up in the multi-thousands of dollars, even with the low end.
Yeah.
So I'm hoping that the IoT stuff eventually does make its way more into the industrial world, and that maybe some of the cheapness problems can be solved with redundancy. Just having lots and lots of things out there, and dual systems, maybe parallel systems, and
Sure. And I think another component of it is just the scale of it. So depending on how many devices you're trying to connect through one router, we had really good stability of the system when, only when we were testing, right? 5 or 10 devices at a time. But then, of course, you go out to the field and deploy it, and it goes from, 5 devices to 500 devices. Whoops, there suddenly some of the things that you weren't anticipating start to show up. And so, it worked great with our off-the-shelf routers that, were laying around in the basement for a few years for the testing, and then we deploy it out in the field, and we end up having to run to Best Buy to get a brand new router, because after a day or two of limping along on this obsolete hardware, we ended up having to replace that. Still cheap, right? Everyone has a Wi-Fi router at home generally, and so you can get started, like you say, with this stuff for a few dollars. Home Assistant is free. There's no license for Home Assistant. You already have a Wi-Fi router. I included the price of some of these in this demonstration so people can really see, how much did you spend on this? Really, $6 in a Tupperware container with some caulking. That's really what it was. The things that cost the most were kind of the power supplies for the LEDs, because those are kind of those tend to be proprietary products with how those are designed. I mean, there's a lot of options out there, but they can get kind of pricey. The LEDs were cheap. I mean, this stuff is really starting to get to the price range where almost anyone can afford it.
So what application might something like power over Ethernet have had, which I think some of that, they have 24-volt versions, but I think they have 48-volt also. And 48 volts would be enough to power a pretty bright LED. Just wiring a whole bunch of cables out to the thing, obviously totally different design, but rather than, when you were talking about physically wiring things, could this have been done with a network of PoE boxes?
That's a really good point. Like have like an industrial switch, right, with 40, 100, or 200 PoE connections, or connection ports to it, and just run one single wire from that base switch to each individual component that you're trying to light up. That's a really good point with the 48 volts because, yeah, LEDs, I didn't know too much about LEDs prior to this project. And when we started wiring them together and saying, how many LEDs can you actually wire together? We were limited to only 6 to 8 LEDs, and the colors made a difference. And it started to get really specific for LEDs getting wired together. So like you said, 48 volts would actually be enough for some pretty hefty LED strip lights. I think that's actually a really good idea. But I would say that generally, most of these really cheap microcontroller devices, they don't have PoE inputs, right? So you don't see, there's not even an Ethernet switch on this. It's Wi-Fi only. That's it. So I could see the cost going up a little bit, but that's worth investigating. I would say that for sure. I'm sure there's something out there.
Well, and I wouldn't be surprised if there wouldn't be a PoE Ethernet, but there would be an Ethernet, direct wired Ethernet capability on some of these microcontrollers.
Yeah, even on the ESP32s and 8266s, I'm sure there is.
Yeah,
I'm
you'd
sure
have to have
there's
a
some
breakout,
boards.
some kind of a power
Yep, some
breakout
type of
kind of
breakout
thing.
board.
The other thing that's possible is with industrial Ethernet, to make things redundant, a lot of times people will daisy chain things and loop it. Which what that does is it means if you ever lose one segment, you're still communicating around the loop. They call it device level ring for Allen Bradley, or a lot of the EtherCAT or Profinet devices are made to chain together. And with power, that could probably, you'd be building a power network and a communication network,
At the
or
same
even,
time.
possibly using other proprietary communication networks. Lots of ways to do this. If you ever had to make it, I love seat of the pants stuff, because when you start out, it's kind of like we've talked before about our remote sensor idea in these plants. You're going to scab together whatever works, and then you're going to learn from it and turn it into, if you ever wanted to turn it into a commercial product, there's lots of things,
There's some additional considerations. Yep, for sure.
Yeah.
So, this ended up working really well for an art installation, right? So if one of these buttons deteriorates and loses functionality, which some did, it's pretty easy for us to go into the system and cover it up, right? We can just say, hey, instead of this button going to this flower, make it go to this flower. Done. Or, hey, some of these flowers aren't lighting up because the button went bad. Make the other buttons light it up as well. And that's really easy to do with this system. We can go in and do it from anywhere. If someone calls and says, hey, button 6 is not working. Okay, that's fine. Whip out your phone and change the firmware at the restaurant. If you're sitting at a restaurant or something, you can do anything, which is pretty cool. But like you said, some of the things that would be necessary in a more commercial system or a commercially viable system, it's not quite there. And part of that's due to our own design, right? We did this super cheap with a little bit more insight and a little bit more, I guess you could say, quality materials or quality workmanship. We could have improved this to where the resiliency or the reliability of it would be higher. But still, it's not going to have the redundancy like you had mentioned with like a loop type system. It's not, it's just not going to have that type of capability unless there's some type of package that's free that I'm unaware of. And with Home Assistant, there are a lot of developers coming up with stuff every day. Um, every few months, there's releases with new features, new functionality. I didn't spend much time looking into the power over Ethernet because, we were doing this as cheap as possible. But there are absolutely power over Ethernet devices, microcontrollers that would fit the bill. Espressive, which is I think it's based out of China. I think they probably have Ethernet microcontrollers available that work with ESP Home. So yeah, I think there's definitely an option to do that. And PoE for LEDs does seem like a really good application because LEDs tend not to be the most power hungry devices out there. And so you could power a lot of different LED devices from that big commercial switch with a built-in power supply. And then you can avoid the cost of all those little individual power supplies.
Well,
I guess there's one additional
ahead.
component that's interesting is since each one of these LED flowers was individually powered and individually controlled, we've got a lot of flowers, and what we're actually going to end up doing is auctioning these off as smart light fixtures. And so we can actually do that because they each have a little ESP30 or 8266 in it that someone can connect to Wi-Fi. We're just going to flash firmware on here to where it creates its own access point, and you can connect it up to Wi-Fi and control it. So that's one way to help get rid of these things.
Yeah, the other thing that this is pointing to for me, and I'm new to the 3D printing world. I still can't even create 3D files, but there's a lot of little boxes and things. Obviously, you're not going to go into commercial versions, but you could print accessories that, I don't know, clips or
Oh yeah,
holders or
absolutely.
whatever that fit. I love the idea. Actually, the Tupperware. I collect little everything from my prescription bottles to big containers for plastic containers for different things. I have a room full of them here in the hopes of eventually using them for things like this, that you can either cut them up or they have lids on them and things like that.
Yep.
And like you said,
Stick a
epoxy or
few,
whatever.
yep, stick some cable glands on it and go.
Exactly. Yeah.
It'd work really well. But I would a word of warning, a lot of times something that comes out of the 3D printer that looks like it's water resistant ends up not being. So even though you print it out of ABS plastic, you would think it's waterproof.
It's porous, yes.
But it ends up being porous. So
yeah, I'm not so much thinking of the container itself because again, we throw away.
There's excellent cheap containers out there already.
Exactly.
Yep, that make a good fit.
I have these psyllium fiber cans. They're pretty good size, and I probably have 40 of them in this back room, and plus all my little prescription bottle cans, and with the screw-on lids. It's not totally watertight, but I'm in hopes of using them for something like this. Putting electronic components inside of it, and it would certainly fit an ESP32 and maybe an Ethernet gland in the end of it or something, to be able to reuse a lot of this stuff. Yeah,
absolutely. And I guess the one last bit of info is, ESP Home is just a plugin for Home Assistant, and Home Assistant was running locally on this device. So if we did lose connectivity, all the buttons still worked. There's no cloud connection technically required. So overall, it ended up being a system that worked. It did its job pretty well. It did require some babysitting, but that was mostly due to, it being free. So you're kind of you can use it with a lot of different hardware that might not be up to the task or not. And so, there's not a sales support engineer available who can say, hey, with Home Assistant, use ASUS routers, not Linksys. They don't work right. Or, hey, don't set everything up as static IP. There, there's just not a lot of knowledge around using it for an application like we ended up using it for. Most of the time, people are using these for, smart home automation, not a system like we were using. So,
What version Pi did you use? A 4 or a 3 or?
we actually used a version
Okay,
3 Pi. So the one that's actually in the photo here.
very cool. I'm hoping to do a lot more with mine. I have several 3s and I have a couple 4s, and really no major project in line. But I've mentioned Pi plates on here before, and I have one that's in an industrial enclosure with the hopes of doing something something that I can test over months, kind of like what you've got, so that I can see how things last. And because I'm just amazed at things like the little portable cameras, little remote access cameras. I put one of these in here 2 years ago, and it's never hung up. Little $49, home remote camera with the pan tilt zoom function on it, and it's been running. And every time I go to it, it's running for 2 years straight. So
Yep.
would love to be able to test more of that using some of this stuff. So Home Assistant is definitely looks like a powerful platform.
Yep. And, I didn't spend much time grabbing screenshots of Home Assistant, but, it's available on the web. There's a lot of instructional videos on how to get started with it. It does a lot of different capability. This past year was called the Year of the Voice. So if you can install a microphone and a speaker like a smart speaker, you can do a lot of the functionality that Amazon Alexa would do. And you can actually do that locally versus in the cloud. So there's a lot of really cool applications with it. Obviously, we didn't implement anything with the smart speaker other than playing music. We didn't incorporate any microphones or anything like that, but that's definitely a component that can be implemented with this system. They spent a lot of developer time the past year making that happen. They just added smart mower, like lawnmower functionality in with it. And most of the smart device manufacturers will have a connector for an API that Home Assistant can grab in. So if you do have cloud devices, existing cloud devices, like a Honeywell thermostat for your house or something, if it's Wi-Fi, it generally has a Home Assistant plugin. So just to put that out there, there's some really cool functionality with it.
Yeah, and I think with all these USB ports on these Pis and everything, you could parallel a lot of things into this and make a separate sound unit that would stream into that or whatever.
Yep,
That's
with
using the
a
horsepower
dedicated
from
sound
something
unit,
else.
exactly.
Yeah.
And kind of reduce some of the latency that we experienced.
Well, very cool, Phil. Yeah, this is there's definitely some people I want to share this with in this area in particular. There's a guy that I used to work with, and he started a company called Third Coast Automation, but he works with an animatics or animatronics company a lot, and they do some kind of light displays and things on a much bigger industrial level. And I think probably in a lot of cases, they're looking for less expensive ways to do this. And as time goes on, I think we're going to get into a lot more kind of industrial applications for this stuff. So very cool.
Absolutely.
Yeah.
So yeah, I thought that would be a really great project worth sharing, and appreciate the time to kind of explain what was behind some of the art installation that happened. So
absolutely,
I really appreciate it.
I'm still hoping to get you up here to the Nashville area. We're only a few hours apart, and get to help me play with some of my stuff. So you're welcome to, of course, stop in during those 2 weeks anytime, and come look at what we're doing if you're in the area. Even that weekend, I'm going to have some guys here from out of town, and we may go out on the town and try to find something fun to do in Nashville over that weekend. We have the 8th through the 19th for that, and then the weekend, guys don't have anything to do, so maybe we can all run out and do something fun.
Yeah, no, I definitely need to try and make a trip up.
Yeah, yeah. Would love, yeah, and we've kind of had some chances to work on things together, but uh, went down to the plant in Miami and have met up a couple times, but would definitely like to work on some microcontroller oriented projects. I bought a whole lot of stuff for an intern here, and
That's what a lot of people do is they end up buying these and then they sit around on the shelf because they don't really, it's like, they kind of they start down the road of doing something interesting or neat with it, and then they run into a hiccup.
yeah,
Right? And
and
then
I don't
it's
know
like,
that I've run into a hiccup. It's a matter of time. I got these little Wi-Fi chips,
mhm.
and I got them to talk to each other. And then kind of the intern was done, and I didn't have the chance to sit down with undedicated time and just play with
Yep,
it.
and
And
just
now,
play
of
with
course,
it
I got this
to
new
do it.
shop. I got a 3D printer. Where do you make time?
Where do you make time? Yep, to play with gadgets and
But they kind of all go together. I still think, the little conveyors and the little microcontrollers and the 3D printer and all this kind of work together. Anyway, I'm going to go ahead and kind of wrap this up here. The next
mhm.
webinar will be December 30th, tentatively, which is right before New Year's, maybe an end of the year wrap up. I have no idea what the topic will be, but if nothing else, whatever I've done in preparation for this workshop, I'll be able to kind of show that. So that's in
Mhm.
about 3
That'll be
weeks.
neat.
So, by that time, the 3D printer will be here. Hopefully, I will have printed something on it, and my mill will be in the little shop, and maybe I'll have some of these little conveyors and pneumatics working. That would be the fun part. And then the rest of it, maybe I'm gonna get free labor for some of these guys that are coming to learn how to do things. Okay, here's how to use a ferrule crimper, and here's how to wire things, and here's some 5 volts and 24 volts and 120 volts, and let's make it all work together. So
Yeah, see if you can optimize the labor.
yeah, we'll see. You got lots of toys here. That's, it's just a matter of getting them implemented into some good working products. I think I mentioned in the last webinar, I managed to find, we were talking about cheap ways to do things. A very good cheap conveyor is a vending machine conveyor. So I got 3 of them for less than $300, and they were about $85 a piece, and they're 24 volts, and they're about, I don't know, 16 inches long, little belt conveyors. They're noisy. They're very bare bones, but a lot
They work.
cheaper than even the Fisher Technique stuff. So
That's really, yeah, that's interesting. Those can definitely be mounted, just 3D print up some good mounts to get them in the right orientation, and you're good to go.
that's kind of what that's one of the reasons I
Hmm.
got the printer. I just thought, I need to make little legs with supports for some kind of C channel, and then
Yep.
go down. I'm headed to Harbor Freight today to get as many of those little pegboard hooks as I can to hang on the
Oh,
walls
sure.
here so I can start organizing things. But
Yep.
in any case, well, thanks everybody for showing up. Thank you, Phil, for your presentation. Definitely learned a lot, and I'll need to kind of go back and watch this and check it out and learn something and install Google Home Assistant on my. I have
Oh,
a
no,
Raspberry
nope,
Pi right
no,
behind me.
no need for Google. It's just called Home Assistant.
Okay, there's no
So
Google anymore. I thought it
there,
was Google Home Assistant.
no, nope. So that's called
Nest.
Google something else. But
Okay.
Home Assistant is a open source project entirely supported by the community, and it's not HomeKit. It's not Apple or Amazon. So it is
Okay. Good to
correct.
know.
So
Yeah.
it's
Well,
not. Yep, not Google.
okay. I thought it was Google Home Assistant, but it's just regular Home Assistant. Cool. Google Nest is, I think, they're one of their brands, but I don't, yeah. Uh,
I'm not sure what Google's is called off the top of my head. I should know since I'm in the space, but I've actually forgotten what Google's platform is called right now.
well, I definitely love the open source kind of stuff anyway. So looking forward to trying that out, and I'll learn
Hmm.
something and maybe put it in a document somewhere in the Automation Academy. Well, thanks, Phil. I'm going to go ahead and call it a day here. Thanks everybody for showing up.
Hey, thank you.